In this video, I'll show you how to open Bruker.d files and process them into absorption mode using AutoVectis. And I'll be processing Bruker files in the FID or FID format, rather than those in the SIR or SER format. The process of converting a Bruker ICR file into absorption mode is known as phase correction or phasing. You can generate a phase correction function for a Bruker ICR file in 3 different ways in AutoVectis. In the first method, you can use information within the spectrum itself to generate its own phase correction function. Alternatively, you can use information that Bruker has saved into the file to generate a theoretical phase function. Or finally, you can apply a phase correction function that you've previously saved for this file or for a similar file. And in this video, I'll take you through all 3 options. So we'll start with the AutoVectis splash screen and click on the AutoVectis logo to open that up. Inside AutoVectis itself, the first job is to choose the file for processing, and we do that by clicking on this Browse button. Bruker.d files are actually folders, so to open such a file, you open the folder and then click Current Folder. Using this control, you can select the type of file you want to process, but in this case it's a Bruker file, so we'll leave it with that setting. The heterodyne checkbox is used if you've collected a narrowband file. Down on this next row, you can choose the number of 0 pads and the mass range of the spectrum you want to process, and then on the far right hand side, choose whether it's an FID or SIR file. In this case it's an FID file, so we won't change that. Then on this next row, you can choose the style of apodization. In this case we'll choose the DPAC mode, and by choosing a fraction of 0.5, that just makes it a symmetrical Han apodization. And then finally at the bottom, this is where you choose how we're going to solve the phase correction function for this particular file. In this case, we're going to choose the recalculate mode, which means that AutoVectis will attempt to solve a phase correction function based only on information within the spectrum itself. To do this, the software will need to brute force fit a phase correction function over a small region of the spectrum, and then extend that out to cover the complete spectrum. AutoVectis has an auto-search method of identifying a suitable small region of the spectrum, and will let it do that by leaving this checkbox checked. And now, having completed the setup, we can hit the Begin button to start the process. So AutoVectis is now loading the data and producing a magnitude mode spectrum for the initial peak detection task. Phase calibration, just like mass calibration, needs to operate on a list of good peaks. AutoVectis will attempt to identify the phasing peak list automatically, and normally it does a pretty good job, but if you need to adjust it, you can do that by modifying the K multiplier or K low limit here on the left hand side. In this case, however, we'll just accept the automatically produced peak list. The next step in the workflow will be AutoVectis attempting to find a phase correction function for a small region of the spectrum using a brute force search. And in this case, we're doing this to the region of the spectrum that AutoVectis chose automatically. This process only usually fails for a couple of reasons. The main reason for failure may be if there's a lot of noise peaks detected in the peak list. Secondly, it may be because there's lots of harmonics in this region, or spurious peaks that don't come from the FT-ICR signal itself. And finally, it may be because there is significant space charge distortion of the peaks in the region. But if your spectra aren't exhibiting any of those features, and let's face it, most do not, then all you'll need to do is click the Accept Calibration function button. And now AutoVectis is using its genetic algorithm to optimize the phase correction function across all regions of the spectrum to produce a final absorption mode spectrum. And now we can use the standard graph zoom tools to zoom into the spectrum to see the detail. The normal magnitude mode spectrum is shown on top for comparison, so that's in red, the upper plot, and then the more highly resolved absorption mode spectrum is shown in green below. So now let's try processing the same spectrum by the ab initio route. You can change the method by which AutoVectis will solve the phase correction function here. We'll go through the other options in a minute, but at this stage we'll choose the use ab initio values, as this will apply a phase correction function based on the way the ions were excited to collect the data for this Bruker file. And we don't need to make any other changes, so we can just hit begin. This workflow begins identically to the previous example. First of all, AutoVectis has to load and Fourier transform the data, and then it will present you with the peak picking tool to identify the peaks to be used for phasing. As with the other example, we'll just accept AutoVectis default settings for peak picking and click the accept button. And then AutoVectis need only optimize the input phase correction function against the spectral data to produce the final result. As you couldn't see any change in the spectrum, we need to zoom into the details so you can show that either of these routes really are equivalent. So we'll keep this view constant and I'll reprocess the data again in the recalculate mode. Once the begin button has started flashing again, that means processing is finished, and even in this zoomed in view, we couldn't see any difference between the spectrum processed by the recalculate route versus the one reprocessed via the ab initio route. For the vast majority of Bruker data files, both of these modes will work well. In the event of some data files which are suffering from space charge effects owing to overfilling the ICR cell, then the difference between the true phase correction function versus what was saved in the Bruker input file may be too different to allow the spectrum to be phased correctly. So under those circumstances, it may be necessary to use the recalculate route. But because of its simplicity and speed, we'd normally recommend the ab initio route as the first port of call for attempting to process any Bruker data. Whichever way you've used to phase correct a file to produce an absorption mode spectra from your Bruker data, you can now save the phase correction function to a calibration file by clicking the Save Phasing Solution button. You can reapply a phasing function to the spectrum from which it was created by choosing the Use Previous for this file option. And this time AutoVectis doesn't need to use the genetic algorithm because it's reapplying a phase correction function to the file that it was originally optimized for. If you want to re-optimize a phase correction function to the current spectrum, then you can choose Use Previous for another file. As the name suggests, this also allows you to use a phase correction function that was generated to a completely different spectrum. Phase correction function files have the suffix .pcf and they're saved in the Bruker.d folder itself. When you want to apply and re-optimize a PCF file, then you can browse for it using this control. Then click Begin to start the automated workflow. In the vast majority of cases, the ab initio route is the only route you will ever need, but you can always re-refer to this video if you want to attempt processing using a different approach. So we hope this video has been useful, and as usual, if you want any other help, you can contact us at autovectis@gmail.com or contact the SpectraSwiss team directly.